maybe overreacting here? I don't really think so, though. The question, we've already seen that we have these special angles, pi over 6, pi over 4, pi over 3. Now, it's not really an issue with the angles 0, pi over 2, pi, even 3 pi over 2. Okay, it's not a problem with angles that stop on one of the axes, because it's real easy to know what the coordinates are when we're on an axis. Okay, that's not an issue. The problem is remembering what the coordinates are that are associated with pi over 6, pi over 4, and pi over 3, because the sign of those angles depend on the first and second coordinates. So that ends up being the real issue. How do we remember the sine and cosine values? And we don't really remember the sine and cosine values so much as we remember the point that we're at when we talk about the angle pi over 6, and the point we're at when we talk about the angle pi over 4, and so on with pi over 3. The rest of what we do in trigonometry, when we get beyond 30 degrees, when we get beyond, when we get out of the first quadrant, for instance, if we were talking about 120 degrees, or if we were talking about 5 pi over 4, or if we were talking about 4 pi over 3, then they all rely on these three angles. They all rely on these three angles. And so it becomes very important for us to think about this, to get this. Now let me remind you, when we saw these points, and I'm just going to remind you that here are the coordinates that showed up. The coordinate 1/2 showed up. Well, the coordinate square root of 2 over 2 showed up, didn't it? And the coordinate 1/2 showed up. And the coordinate square root of 3 over 2 showed up, okay? Those were the coordinates that showed up. Now, where they were they first coordinates, second coordinates, that's a little more of an issue. So let me draw, okay, a unit circle that's real big, except we're just going to look at it in the first quadrant, because that's really the place that I'm worried about. So let's say up here's where 1 is. Okay, please don't laugh at me. There's the unit circle, first quadrant. So the coordinates of this point, of course, are 1, 0. And the coordinates of this point, of course, are 0, 1. Now, we've got three angles that I want to consider. And the angle pi over 4 would be 45 degrees. And so it just goes right down the middle, doesn't it? Okay, so let's extend this out so that I have room to talk about it. Okay, I guess just go like this. So this is the angle pi over 4, which is the same as the 45-degree angle. So I'm interested in the coordinates of this point. Now this one's the easy one to remember. Okay, it's easy to remember, and this is what you remember. The coordinates are the same. And which one has the coordinates are the same? That is where we have square root of 2 over 2. So this one we just have to remember is the square root of 2 over 2 that's involved. Okay, and we've got that handled. Now it's the other two that we have trouble with getting backwards or remembering. So let's consider the other two angles. Okay, so 30 degrees would be roughly along here. So that's pi over 6, and that's the same thing as 30 degrees. And we need to know the coordinates of this point. Okay. Now, what I'm telling you when I'm looking at that point, I know it involves. See, when I know that 1/2 and square root of 3 over 2 are involved. I've got to remember that much. Okay, they're involved. Now, of which way? Well, here's the way I remember it. Let me tell you how I remember it. I know that 1/2, I know what the value 1/2 looks like. And let me tell you the square root of 3 over 2. Square root of 3 is about 1.7. And so if I divide that by 2, that's approximately 0.85. So when I look at the point that I'm talking about, so I'm talking about the point here, and I'm trying to figure out what coordinates I have, and does the 1/2 go in the first position or the second position? We'll look at the point. Look at the point. If I look down here, does that look like that's 1/2? Does that x value look like 1/2? No, that looks like it's close to 1, which to me it looks like it's 0.85. So that first coordinate's not 1/2. It has to be the other combination, square root of 3 over 2. Now, What about the second coordinate? Well, look, just look at the second coordinate. Where would that put me over here? Oh, yeah, that looks pretty much like 1/2, doesn't it? And so we see how that fits together. Now, our other special angle, of course, is pi over 3, which is 60 degrees. And that would be roughly, okay, now remember, I'm just sketching that, but that would be roughly about here. Okay, so this would be where pi over 3 is, and that's, remember, the same as 60 degrees. Now, I'm interested in the coordinates of this point. And I know the coordinates of the point involve a 1/2 and a square root of 3 over 2. Now, I could remember they're the reverse of pi over 6, but let's do the same thing. I know 1/2 and square root of 3 over 2 are going to be involved. That's what I know is going to be involved, because square root of 2 over 2 belongs to one special one, doesn't it? Okay. Now, when I look at this and I say, okay, well, consider the first coordinate. Well, if I look at that first coordinate, you know, my diagram's not perfect, but it certainly isn't 0.85, so it looks clearly like it's about 1/2, isn't it? Again, my diagram's not perfect, but understand, it looks about 1/2. And so the inaccuracy is my diagram, I can say, oh, since I know 1/2 or square root of 3 over 2 is involved, the first coordinate's got to be 1/2. Now, when I look at the second coordinate, well, yeah, look, the second coordinate's clearly not 1/2, and the second coordinate looks like it's almost 1, and 0.85 is almost 1, and that's square root of 3 over 2, so we know the second coordinate is the square root of 3 over 2. So that's the way I make the decisions. Now, you have to have a way to remember what these points are, but once we know these points, see, once we know these points, and someone can out of the blue say, okay, what is the value of the tangent of, let's say, pi over 6? Well, here's the process we go through. Find the point, find the coordinates. Okay, well, what are the coordinates? Well, pi over 6, we've got to remember how to remember the coordinates. So the coordinates are the square root of 3 over 2, comma 1/2. Okay, now from that, we know, that the sine of pi over 6 is 1/2. And we know the cosine of pi over 6 is the square root of 3 over 2. And we know that the tangent of any angle is the sine of that angle divided by the cosine of that angle. Okay, and from knowing the point, we know that the sine of that angle is 1/2, and we know the cosine of that angle is the square root of 3 over 2. And so that would end up, you know, when we invert and multiply, when we multiply by the reciprocal, we have 1/2 times 2 over the square root of 3, and that's 1 over the square root of 3, and then we've been through it. I'm not going to do it. Well, I guess I'll show it. We rationalize that, and we get the square root of 3 over 3. So we have to know the points. From the points, we get the values of sine and cosine, and then we remember the formulas for tangent, cotangent, secant, and cosecant. That's the way we can memorize it. And what you've seen is we didn't really memorize. What did we memorize? We memorize these coordinates are involved and roughly where the angles are that we're talking about, so we can decide which of these coordinates go in which positions. Yeah, you may want to just memorize those, but I suggest later on there's so much to memorize that that's a difficult task. Okay, let's move on to another topic. Very soon we're going to be asked to find the sine of 5 pi over 4, or find the sine of negative 2 pi over 3, find the cosine of 135 degrees. We're going to be asked to find those, and they all rely, the first stage, they all will rely on these special angles that we have some information about now. But we have to move around the unit circle in ways so that we can locate new points that we haven't located so far. Our points so far have been in the first quadrant. And so to do this, it's what I call counting off angles. And so, for instance, we might need to count by pi over 4s, or count by pi over 6s, or count by pi over 3s, or by pi's, okay, as an example. So here's what I mean by this. Let's stop and think. The first is, well, I say let's stop and think. When I'm talking about pi over 4s, so the idea is 1 pi over 4. That's certainly just pi over 4. 2 pi over 4s. Well, it's like 2 times pi over 4s. Pi over 4, 2 times in succession. Well, 2 pi over 4s is 2 pi divided by 4, and that reduces to pi over, that reduces to pi over 2. 1 pi over 4 is pi over 4. I'm sorry, above. I thought, what's he talking about? 3 pi over 4s. Well, that's pi over 4 in succession 3 times, but it's the same as pi over 4 plus pi over 4 plus pi over 4, or 3 times pi over 4, which would be 3 pi over 4. Or 4 pi over 4s. Again, that's a pi over 4 plus a pi over 4 plus pi over 4 plus pi over 4. And that's the same as 4 pi over 4, which is just a simple pi. And then we could have 5 pi over 4. Okay, well, 5 pi over 4s is the same as 5 pi over 4, but it's 5 pi over 4s in succession. Now, again, what in the world does that have to do with anything else when I say count by pi over 4s? Well, let me draw a unit circle here. Now, in this unit circle, I guess I drew the circle and didn't draw the axis, did I? Okay, I've got a unit circle, so of course this is the point 1 comma 0. Now, pi over 4 is roughly right here. There's pi over 4. And we know the coordinates of that point. That point has coordinates square root of 2 over 2, comma square root of 2 over 2. That's something that we've been working on. Now, this is pi over 4. Now, think about if I put 2 of those together. See, 2 pi over 4s. Here's the first pi over 4. We move this distance. See, we move this distance. And for the second pi over 4, we're going to start there and move that distance again. And where does that put us? That puts us right here, doesn't it? So this is 2 pi over 4, which we recognize is the same as pi over 2. We already knew that. So I'm thinking about, well, where is 5 pi over 4? So let's think, where is 5 pi over 4? Okay, well, there's 1 pi over 4. Now I've gone 2 pi over 4s. If I go that distance again, then that's going to put me roughly right here. So it's going to put me roughly right here. So I'm going to go pi over 4 again. That puts me in this position. So 1 pi over 4, 2 pi over 4. This is the third pi over 4, isn't it? 3 pi over 4. So this is where 3 pi over 4 is. Now the significance here is we can already determine the coordinates of this point. See, the coordinates of this point. So, we're talking about this angle being the angle 3 pi over 4, which is this angle right here, isn't it? See, that's the angle that we're really talking about. Now, what are the coordinates of that point? Well, because of the symmetry of this unit circle, the second coordinate is identical to the one we've got here, isn't it? It's the square root of 2 over 2. the first coordinate is just in the opposite direction. So it's negative square root of 2 over 2. See, I'm referring to this point to make this decision. Okay? But we see, oh yeah, the second coordinate is exactly the same, but the first coordinate is just opposite. Okay? Now that's at 3 pi over 4. If we go pi over 4 again, after 3 pi over 4, how many pi over 4s do we have? 4 of them. So this position is 4 pi over 4. It's 4 of these pi over 4s, which we recognize anyway as pi. So we already knew that. Okay, well, what about 5 pi over 4? Well, we go pi over 4 again. Well, where will that put us? See, that will put us, we do that again, that'll put us about right here, won't it? Oh, I've gone a little too far. Put us about right here. See, that's where we will be if we go another pi over 4. So this position, let's see, where are we? Here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Now we're at 5 pi over 4. This is 5 pi over 4. Now, of course, the angle is all around. I'm just looking at where we are, I'm just looking at where we are when we stop, okay? But the angle, of course, 5 pi over 4 is this angle right there, isn't it? Okay, so 5 pi over 4. Now, what are the coordinates of that? Well, what I'm going to do to decide the coordinates of that is I'm going to look at this angle, okay? And I look at the coordinates of that point, I guess I should say. So I consider, well, now, the first coordinate's the same. They have the same x value, don't they? They have the same x value. So the first coordinate's the same. It's negative square root of 2 over 2. Now the second coordinate, second coordinate up here, the second coordinate is positive. Down here it will just be the opposite of that. It will be negative, but it's just the opposite direction, isn't it? So it's negative square root of 2 over 2. And of course that makes sense. In the third quadrant, which we are, the x and y coordinates are both negative. But now we know the coordinates of that point. So if someone came along and asked us, what's the sine of 5 pi over 4? Okay, well, here's what I'd do, is I'd count off 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Here I am. What are the coordinates at that point? They're all based on the coordinates of this point. And so I look at the coordinates of that point, negative square root of 2, comma negative square root of 2. Sine is the second coordinate, so it's negative square root of 2 over 2. Let's continue counting. 6 pi over 4, so we would go this distance again. 6 pi over 4 puts us right here. Okay, that's 6 pi over 4. Now when we simplify that, we get the same as 3 pi over 2. So that's the same location as 3 pi over 2. And of course, there we can calculate because we know the coordinates of that point. Okay, the coordinates of that point, remember we're on the unit circle, and the x value is 0, but the y value is negative 1, isn't it? And so now we can answer the question, what's the sine of 3 pi over 2? Oh, it's negative 1. Okay, now that's the same as 6 pi over 4. What if we count one more time? We'll go pi over 4 again. If we go pi over 4 again, it's going to put us roughly here, isn't it? See, here's another pi over 4. It's going to put us roughly here. Okay, so what is that now? That's 7 pi over 4, isn't it? It's a pi over 4 beyond 6 pi over 4. So this is 7 pi over 4. Well, now what are the coordinates of that point? Well, all we have to do is kind of line up, oh, well, it's related to the point here, and it's related to the point here, isn't it? Or we could just say it's related to the point directly above it. It has exactly the same x value, but the y values are opposite. So this is negative square root of 2 over 2, and I'm looking way back up here at this point, and did I write a 3 as that denominator, or did it just come out ugly? I can't tell. That's square root of 2 over 2. I apologize for that. And so now we have the coordinates of this point. So now if we wanted to know about, if we wanted to know about 9 pi over 4, what would we do? we'd start 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7 pi over 4, 8 pi over 4, 9 pi over 4, we're right back here, aren't we? Or if we wanted to count by negatives, if we wanted to know where negative 3 pi over 4 is, well, we start at this position always, and so we'd go negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. So this is the same place as negative 3 pi over 4, and we know the coordinates, here they are, so we could easily find sine and cosine of negative 3 pi over 4. And if we know sine and cosine, then we can calculate all of the other trigonometric functions. So that's what I mean by counting by pi over 4s. Let's continue this. Let's continue this on the next page and count by pi over 3s. Well, we had a little change of word here. I said count by pi over 3s. Let's first count by pi over 6s. Okay, and let's understand that this is what we want to know. We want to know the tangent of pi over 6. Excuse me, I'm really messing up here. We want to calculate or determine the tangent of 5 pi over 6. That's what we want to do. Okay? So to do that, we need to locate our point. We need to count by pi over 6. And here's what I mean. First, we locate pi over 6. Okay, let's say this is where pi over 6 is. Okay, that's the angle pi over 6. Now, what are the coordinates of that point? When I say that's the angle, you recognize what I mean is the angle is here, but it intersects the unit circle at this position. So I'm not going to draw the terminal side each time. I'm just going to locate the position on the unit circle. Now, remember what the coordinates are of this point? Well, maybe not exactly. What we remember is it involves 1/2 and square root of 3 over 2. So when we look at that point and we look at the first coordinate position, which would be right down here, wouldn't it? Well, that's certainly not 1/2. And so we conclude, oh, that's the square root of 3 over 2. And when we look at the second position, and of course I'm not exact here. I'm not exact. This is where our circle is up here. I got some overlap, don't I? And I apologize. Then the second coordinate is about here, okay, and that looks like, oh yeah, since I know the other coordinate actually has to be 1/2, and that looks very reasonable. Okay, so I know the coordinates of that point. Yeah, I'm interested in the tangent of 5 pi over 6, and so I have to find out where that is. Okay, so here's what I've done. I've done pi over 6, okay, to get to here. Now I'm going to take that amount and go pi over 6 again. And when I go pi over 6 again, it puts me at this position. Now, let's understand where this is. This is 2 of those pi over 6s. And 2 pi over 6 is the same as pi over 3. And so we know the coordinates of that point. Okay, that's pi over 3, which is 2 pi over 6s. And the coordinates of that point are going to be a 1/2 comma square root of 3 over 2. But of course, we're not interested in pi over 3. We're interested in 5 pi over 6, aren't we? So okay, let's go more. So if we do a pi over 6 additional, look, that puts us right here. See, how many of these pi over 6s are there in this first quadrant? Well, there's 3 of them, because this is 3 of these pi over 6s, which if we simplify that, 3 over 6 is 1 over 2. This is pi over 2. We already knew that. That's where 3 pi over 6 is. Now we want to know about 4 pi over 6. Well, we go that distance again. Okay? So that puts us right here. That puts us at this position. See? what's happening here? So this is 4 power 6, isn't it? This position is 4 power 6. Remember, here's 1, here's 2, here's 3, here's 4. 4 power 6 simplifies. 2 goes into 4 2 times and 6 3 times. This is 2 pi over 3. Oh, we're kind of doubling up here, huh? So now we're going to go that distance again. Go that distance again. Oh, that puts us right here. This is 5 pi over 6. We're finally at the place we need to be, okay? So what are the coordinates of this point? What are the coordinates of this point? Because we need to know, see, here's the thing down below. Tangent of 5 pi over 6 is the same as the sine of the angle 5 pi over 6 divided by the cosine of 5 pi over 6. And the sine of pi over 6 is going to be the first coordinate at our point. So now we need to know these points. Well, these coordinates. We're going to use the coordinates that we know here. See what we've already started with. And look, the second coordinate is identical, but the first coordinate is opposite, isn't it? So this is negative square root of 3 over 2 for our first coordinate, and a positive 1/2 for our second coordinate. Okay, so there we are with 5 pi over 6. So our sine of 5 pi over 6 is that second coordinate, 1/2. Our cosine of 5 pi over 6 is that first coordinate, negative square root of 3 over 2. And then when we simplify this, we'll have our 1/2 times the reciprocal of our divisor, which will be negative 2 over the square root of 3. Now we'll get the 2's canceling, and we'll end up with, we come down here, we'll end up with negative 1 over the square root of 3, and then when we rationalize that, we'll end up with negative square root of 3 over 3. But what we did is we counted by pi over 6's to get there. Now, let's continue what we're thinking of this. That's the motivation of why we would want to do it. If we go pi over 6 again, that would be right here, wouldn't it? That'd be right here. And so that would be 6 pi over 6, which is simply pi. And we know the coordinates of that point. If we go pi over 6 again, it'll put us right here. Okay, if we go pi over 6 again, it puts us right here. So that's another pi over 6. That's 7 of them. 7 pi over 6. Okay, 7 pi over 6 is this point. Well, now, what are the coordinates of that point? What we do is we look above. Okay, we look above. Well, it has the same first coordinate as that point above, doesn't it? And its second coordinate is the same value, but opposite in sign. So now we know the coordinates of that point. Now, where does this put us? If we go pi over 6 again, we'll go right here, won't we? So it would be at this point. So this is 8 pi over 6. Well, 8 pi over 6, if we simplify that, 2 goes into 8 4 times and into 6 3 times. So this is the same as 4 pi over 3. Oh, we're kind of counting out, well, we'll do this again here in a moment. Now, if we go again, okay, we go again, pi over 6, 9 pi over 6 puts us right here. 9 pi over 6. But now 3 goes into 9 3 times and into 6 2 times. That's 3 pi over 2. So there's 3 pi over 2. Okay, let's go again. Okay, we go again. We're at this position. Okay, this position. Well, that position is 1 more pi over 6. This is 10 pi over 6. But 2 goes into 10 5 times and into 6 3 times. This is the same as 5 pi over 3. When we go pi over 6 again, that would put us right here, okay, at this point. So that would be 1 more pi over 6, 1 more than 10 of them. This is 11 pi over 6. Now that position, okay, that won't simplify, will it? That won't reduce. Okay, so what are the coordinates of that point? Well, all we have to do is look above. Say, look at the point above it. Well, it has the same first coordinate, which is the square root of 3 over 2. The second coordinate is opposite of 1/2, is -1/2. So now we could easily find the tangent of 11 pi over 6. We could find the secant of 11 pi over 6 because we know the coordinates of the points, don't we? So that's what I mean by counting off by pi over 6s. And if we went one more time, say if we went another pi over 6, it would put us back here at the beginning, which is the same position as 0, or it would be 12 pi over 6, and 12 over 6 is 2. This is the same position as 2 pi. Okay, and we can label off. Now, notice in this process here, what else has happened? Here we have pi over 3. This is 1 pi over 3, okay? And so that's going from here to here. Now, if we go pi over 3 again, that puts us over to here, okay? And that's 2 pi over 3. And if we go pi over 3 again, that puts us here, which is 3 pi over 3, which is the same thing as pi. If we go pi over 3 again, that puts us to here, that's 4 pi over 3. If we go pi over 3 again, that puts us to here, that's 5 pi over 3. And if we go pi over 3 again, that puts us to here, that's 6 pi over 3, which is the same as 2 pi. So here is 1 pi over 3, here is 2 pi over 3, here is 3 pi over 3, here is 4 pi over 3, here is 5 pi over 3, and back to here is 6 pi over 3. Now, what about these points? See, 1 pi over 3 has this point. 2 pi over 3, well, what would be that point? Let's go over and look and say, what are we doing? We're comparing to this point. And so we have the opposite first coordinate, but the same second coordinate. So for 2 pi over 3, those are the coordinates that we're interested in. Okay, well, what about, we really don't care about 3 pi over 3 because that's just pi, that's here. 4 pi over 3 is here, okay? So what are the coordinates associated with this point? Well, what do? We look way back up here at 2 pi over 3. See, we look way back up here. And we have the same second coordinate, which is -1/2, so -1/2. But the same first coordinate. The second coordinate is opposite in sign, so it's a negative square root of 3 over 2. Now, if we go pi over 3 again, we'll be at 5 pi over 3, that's here. Okay. What are the coordinates of this point? Well, we look back up here and say, look, this is just opposite of that point across the x-axis, isn't it? And so it has exactly the same first coordinate, but the second coordinate is negative instead of positive, so it's negative square root of 3 over 2. And so now we can count by pi over 3s. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, and we can determine the values of the points, the coordinates of the points, and that will take care of everything we want to know. Well, we're going to practice this on the next page, but that's the idea by counting by pi over 3s or pi over 6s. Okay, we're asked to find here the exact value of the tangent of 8 pi. Okay, so let me show you what I'm going to do. I'm going to count by pi's, or I'm going to count by pi's or 2 pi's here, but so I'm thinking of a unit circle. Okay, so we've got this unit circle. I don't have to be exact here. I'm just trying to get an idea. And so I need to know where 8 pi leaves me. Remember, this is always the starting position right here. Now 1 pi, say pi, is clear to the other side. That's pi, isn't it? So if I go pi again, it puts me back to here. That's 2 pi. If I go pi again, it puts me back to here. That's 3 pi. If I go pi again, it puts me back to here. That's 4 pi. Okay? Then back to here would be 5 pi. and then again to here would be 6 pi, and then to here again would be 7 pi, and then to here again would be 8 pi. Now, it would have been a little easier if I would have thought that if I go around one time, it's 2 pi, and if I go around 2 times, it's 4 pi. See, that would have been a little easier. Thinking, if I would have gone all the way around one time, that's 2 pi. And so if I do that again, that's 4 pi. And if I do that again, that's 6 pi. If I do that again, that's 8 pi. Bottom line is 8 pi puts us at this position, which is the same as our starting position, but that point is 1 comma 0, isn't it? That point is 1 comma 0. Okay, so here's the next thing I need to know. I need to know that the tangent of 8 pi is calculated by saying it's the sine of the angle, so it's the sine of 8 pi divided by the cosine of the angle, so it's the cosine of 8 pi. Now the sine of 8 pi is the second coordinate of the point we're at, and the second coordinate of the point is 0, isn't it? And the cosine of 8 pi is the first coordinate of the point we're at, and that first coordinate is 1. And so the result here is 0 over 1, which is 0. So the tangent of 8 pi is equal to 0. Well, here we're to find the exact value now of the cotangent of 13 pi over 4. So we need to locate where 13 pi over 4 is. And so we could count off 13 separate pi over 4s, couldn't we? That would be a way to accomplish it. And so if we were doing that, we would set up a unit circle, just something for us to deal with. And we'll say, okay, here's the first pi over 4. Here's the second pi over 4. Here's the third pi over 4. Here's the fourth pi over 4. The fifth, the sixth, the seventh, the eighth. 8 pi over 4 is right here, which is 2 pi. So in the future, we might remember if we go all the right way around, that's 2 pi or 8 pi over 4s. Okay, now where are we now? There's 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4. Finally, 13 pi over 4 puts us right here. Now, what are the coordinates of that point? Well, with pi over 4, the coordinates are the same, but maybe opposite in sign, right? But in this case, remember up here, the coordinates are at 1 pi over 4 are square root of 2 over 2, comma square root of 2 over 2. And so they're going to be related to those. But here, both of our coordinates are negative because we're in the third quadrant, aren't we? So we get negative square root of 2 over 2, comma negative square root of 2 over 2. So that's how we make that decision. Okay. Now that we have that information, what's the cotangent of 13 pi over 4? Well, what we would want to remember is the way we calculate cotangent is we take the cosine of the angle, so it's the cosine of 13 pi over 4, divided by the sine of the angle. That's the sine of 13 pi over 4. And of course, in this case, the cosine is negative square root of 2 over 2. And the sine is also negative square root of 2 over 2. Well, when we're dividing by the same number, although they're both negative, negative over negative is positive, and if the numerator and denominator are the same, the value is 1, so the cotangent of 13 pi over 4 is equal to 1. Well, let's do yet another one. Let's calculate okay. Find the exact value of the sine of 7 pi over 6. So now we're going to have to count by pi over 6s. How many are we going to count off? We're going to count 7 of them off. So let's get our little diagram, just something to refer to for our unit circle. There's our unit circle. Now remember, pi over 6 is about 30 degrees. So this is pi over 6. And we know the coordinates of that point. How am I remembering the coordinates of that point? I'm looking at what possible first coordinate. Remember, the two coordinates that are going to be involved are 1/2 and the square root of 3 over 2. But when I look at the coordinates of that point, I know the first, because remember, this is where 1 is right here. I know the first coordinate couldn't be 1/2. That's got to be the square root of 3 over 2. And then when I look at the second coordinate, yeah, that would be along here. That looks like that's about 1/2, so that's reasonable, isn't it? So we know the coordinates of that point. Now we've got to count off 7 of these pi over 6s. Well, remember, 2 pi over 6 puts us right here. And 3 pi over 6 puts us right here. And 4 pi over 6 puts us here. I did that kind of bad. That's 4. This is 5 pi over 6. This is 6 pi over 6. And so 7 pi over 6 is roughly right here. Okay, that's where 7 pi over 6 is, and I was a little bit sloppy. Well, now, what are the coordinates involved? They're related to the coordinates of this one, aren't they? And the coordinate here, I can see that the first coordinate is negative, and it's got to be that square root of 3 over 2. It can't be negative 1/2. But the second coordinate is also negative, but yes, it is negative 1/2. Okay, so now to calculate or determine the sine of 7 pi over 6, then we're looking at the second coordinate of that point, and since we know the coordinates of that point, we know that value is negative 1/2. So it's really pretty easy to do when we understand the process that we're going through. So remember how we did this. There was 1 pi over 6. Here's 2 pi over 6, which happens to simplify to pi over 3. And here was 3 pi over 6, which simplifies to pi over 2. And this is 4 pi over 6, which simplifies to 2 pi over 3. And this was 5 pi over 6, which doesn't simplify. And this is 6 pi over 6, which simplifies to pi. And finally, we got to 7 pi over 6. Let's do a couple more on the next page. Okay, to find the exact value of the secant of 4 pi over 3, we're going to have to count off 4 of these pi over 3s, aren't we? That's the way I think of this. So I start out with my unit circle once again. Just so that I have something to refer to. And I've got to know where 1 pi over 3 is. See, and pi over 3, remember, is roughly the same as 60 degrees. It is the same as 60 degrees. So this is where pi over 3 is. Now, I have to remember what the coordinates of that point are. And again, I remember it involves a 1/2 and a square root of 3 over 2. I just got to figure out which goes where. And when I look at the x value of this point, I'm really looking down here at the x-axis. Oh, okay, that's clearly a 1/2. And so the y-coordinate, as we look at the y-coordinate, that's almost 1, which is square root of 3 over 2 is almost 1. So now we know the coordinates of that point. Okay, so now we have to count off by pi over 3s. Now another pi over 3 is going to put us roughly right here. So this is where 2 pi over 3 is. Let's just keep that in mind. And when I go pi over 3 once again, it puts me here. So this is 3 pi over 3, which we call pi, don't we? Now if we do that again, 4 pi over 3 will put us right here. So 4 pi over 3, and that's the point we're interested in, isn't it? That's the angle we're interested in, which is this angle. But what we need to know are these particular points, the coordinates of this particular point. And so we say, okay, let's consider, because we already know about the symmetry of this circle, and actually it would be more symmetric to what we have up there. Let's come back. We know it's going to involve these coordinates, except the first coordinate is going to be negative in value. It's going to be negative 1/2, and the second coordinate is also going to be negative, so it's going to be negative square root of 3 over 2. Well, now that we know the points, okay, the point, okay, now we're able to consider calculating the secant of 4 pi over 3. So we know the coordinates of that angle, that trig point that angle puts us at. Now we've got to remember the way we calculate the secant of an angle, it's 1 over what? It's 1 over the cosine of the angle, isn't it? So that's the part that we have to remember. Now, the cosine of the angle is the first coordinate of the point on the unit circle. And the first coordinate here is a negative 1/2. And so now we're going to multiply by the reciprocal of negative 1/2, which is negative 2 over 1. And you see we get a result here, of course, then of negative 2. So the secant of 4 pi over 3 is negative 2. Now, we've gotten used to counting by radians, but sometimes we need to count by other means. And so let me just kind of throw this out in this fashion. We know, okay, this is pi over 4, which is the same as 45 degrees. Okay, if we go 2 pi over 4, that's 2 45 degrees, which is, of course, 90 degrees. If we go 3 pi over 4, or 3 of these 45 degrees, okay, this is 3 times 45 degrees, which is 135 degrees. I mean, it's really 90 degrees plus 45 more, isn't it? And if we go 4 of these 45 degrees, of course, that puts us at 90 degrees. And if we go 5 of these 4 pi over 3s, then that puts us at, did I say 90 degrees? I'm sorry, that's 290 degrees. That's 180 degrees, isn't it? And if we go 45 degrees more, then that'd be 180 plus 45 degrees. That's 225 degrees. That's right here, isn't it? And if we go 45 degrees more, that puts us right here, which is 270 degrees. If we go 45 degrees more, that puts us right here, and that's 315 degrees. And if we go 45 degrees more, that puts us here at 360 degrees. So here's 45 degrees, here's 90 degrees, here's 135 degrees, here's 180 degrees, 225 degrees, 270, 315, 360. And because we know this one point, see the point right here, we know that point is the square root of 2 over 2, comma, the square root of 2 over 2. And so because of that information, someone could come and ask us, well, what's the cosine of 135 degrees? Well, what we would do is we'd come along here and we'd say, okay, well, where is that 135 degrees? Oh, it's right here. Now, what are the coordinates of that point? Well, we look at this point. And the coordinates are the same values, but maybe with different signs. And we say, oh, well, the cosine is the first coordinate of that point. And we can see that that point, we can see that that point has a first coordinate that is opposite of the one that we have here, opposite of this point. So that's negative square root of 2 over 2. The second coordinate, we have the same y value. See, it's going up the same amount. It's just going to the left instead of to the right. And so going to the left causes it to be negative. Going up in both cases is still square root of 2 over 2. Well, all we're really interested in, though, for the cosine is the first coordinate. So the cosine of 135 degrees is negative square root of 2 over 2. Well, what about cosine of 330 degrees? So let's extend this idea, this unit circle idea. I probably need more room than I'm making here. Now remember, this is pi over 6, which is the same as 30 degrees, and we know that the coordinates of that point are square root of 3 over 2, comma 1/2, from the things that we've done before. Okay, I guess it should be more like this. Now, this is roughly where 60 degrees is. And we know the coordinates of that point, okay, we know that that has a first coordinate of 1/2 and a second coordinate of the square root of 3 over 2. And of course, this is where 90 degrees is. If we go 30 degrees more, okay, if we go 30 degrees more, this is going to be 120 degrees. See, here's 90 degrees. So I'm just counting off kind of by 30 degrees. But look, this point and this point are related, aren't they? If I go 30 degrees again, that's going to put me at 150 degrees. Okay, so here's 150 degrees, and the point we have here and the point we have here are related. If I go 30 degrees more, it's going to put me at 180 degrees. If I go 30 degrees more, it's going to put me at 210 degrees. If I go 30 degrees more, it's going to put me at 240 degrees. If I go 30 degrees more, it's going to put me at 270. 30 degrees more is going to put me at 300 degrees. 30 degrees more is going to put me at 330 degrees. And 30 degrees more is going to put me at 360 degrees, okay? So what we have to decide is when we're dealing with 330 degrees, what is the point? Or better, what are the coordinates of the point? Well, here's where 330 degrees is, and it's related to the point that we have here, isn't it? And so when we look at that point, see, that let's just consider the coordinates of that point. It has the same first coordinates of this point. See, same first coordinate as this, square root of 3 over 2. And the second coordinate is opposite in sign. It's a 1/2, but it's a negative 1/2, isn't it? So now that we know that, we can say, oh, the cosine of 330 degrees is the first coordinate of that point, which is square root of 3 over 2. And as far as that goes, we could say, oh, the sine of 330 degrees is negative 1/2. Or as far as that goes, we could say the tangent of 330 degrees is whatever the sine of 330 degrees divided by the cosine of 330 degrees is. So once we know how to navigate around the unit circle for these special angles and multiples of these special angles, we can do our work. Well, but not all angles are multiples of these special angles. Oops. Special angles. See, what about the cosine of 5 pi over 7? Or the tangent of 13 pi over 5, or the sine of 340 degrees. See, in all of these cases, we don't have multiples of, we didn't have anything about pi over 7s. We didn't have anything about pi over 5s. And when we look above, we see 340 degrees doesn't fall in one of those nice places, does it? So in all of these cases, we must approximate the values by using a calculator. We just don't have any choice. And I think that's where we'll stop about how we calculate the trig functions of special angles and multiples of special angles.